Hello everyone and welcome to this video. Today is our last part of Introduction to Organic Chemistry, Organic Reactions and Mechanisms. Let's start. So what do we mean by organic reactions and mechanism? We mean by that in organic chemistry the reaction that involves breaking of bonds and the formation of new bonds in organic chemistry. There are two types of breaking bonds in organic chemistry, either hemolytic fission or heterolytic fission. Let's start with the hemolytic fission. In case of hemolytic fission, we all know that a covalent bond forms due to the sharing of two electrons between two atoms. In the hemolytic fission, the breaking of the bond ends up by allowing each atom to take away its electron back again. So you will have, in case of Cl2, in that case you will have two Cl atoms. Each one of them will have only 7 electrons in the outermost shell. The produced species we call them radicals. Radicals are very active. The reactions of those two of radicals usually involve with three major steps. The initiation step that produces the free radicals, like we've seen in the other slide. Then propagation step, where those radicals would attack other molecules to form longer chains, and lastly termination step, where the reaction would just stop by the radicals attacking each other, reforming a stable molecule. Now the heterolytic fission, on the other hand, this is the second type of breaking the bond in organic compounds. So we talked about the hemolytic fission. This one is the heterolytic fission. Heterolytic fission because each atom will end up with uneven number of electrons that they started with. So you have this covalent bond, so between the H and Cl, and breaking this bond doesn't end up by the hydrogen taking away its electron and the Cl takes away its electron. Instead, the chlorine atom would just take away the two electrons. So the breaking of the bond in that case would result in the formation of what we call positive ion and negative ion. Now if you looked at the formation of the carbon cations in case of the heterolytic fission, you could see that the alkyl group will have what we call a positive inductive effect on the adjacent group. In here you could see that this carbon atom is carrying the positive charge, and this alkyl group is actually allowing for the distribution of the positive charge on this carbon and the adjacent group. This is what we call the inductive effect. So in here, this is the secondary carbon cation. So I have here the primary carbon cation, which is least stable. In here I have the secondary carbon cation, where I have two alkyl group, and in case of the tertiary carbon cation, it is very stable, most stable, because I have these three alkyl groups that allow for the distribution of the positive charge of this positive carbon on the three alkyl groups. This smearing effect of the charge, the positive charge on the three alkyl group plus the positive carbon atom, will allow for the formation of stable intermediate, which is the tertiary carbon cation. This inductive effect, the positive inductive effect, you could see that it increases by increasing the number of alkyl groups, and it will lead to a more stable carbon cation in case of the tertiary carbon cation. Now moving to the types of the organic reactions. So we talked about how breaking of the bond happens, either hemolytic or heterolytic. In the hemolytic, we said electrons, one of the electrons just each atom ends up with one electron, but in the heterolytic, just one atom will take away the two electrons of the bond, and one of them will form the positive ion, or what we call positive carbon cation. Now for the type of organic reactions, you either have those type of reactions in here: addition, elimination, substitution, oxidation, reduction, and finally the hydrolysis. Now let's start with the addition reaction. In the addition reaction, from the name you could see that something will be added to something else, and you could see that I will start with two compounds and I will end up with one product. So you have two reactants and you will have one product. For the elimination reaction, this means something will be taken away from the molecule. So you will have a decrease in the molecular weight of your compound because you will take away something like water, eliminating water from your compound. So in here, the concentrated sulfuric acid takes away water molecule from the alcohol and forming the alkene. Now for the substitution reaction, what will happen? One of the hydrogens will be replaced by another atom. In that case, it is replaced by chlorine atom. So we are taking away one atom and replace it with something else. Now if we looked at the hydrolysis reaction, in that case a breaking would happen using water molecule and you will have a new compound with hydroxyl group. In here you could see that we can speed up because breaking bond using water is very slow, so we can speed up this reaction by the addition or using alkaline solution or acid solution. Your major compound will not be affected by this replacement but your side product is the one will be changing. So here you had a hydrogen bromide, but in here you could see that you will have sodium bromide due to the addition of alkaline solution instead of water. Now for the oxidation reaction, it is similar to the oxidation reaction in inorganic compounds, but in here it is easier to identify the oxidation or reduction because you don't look at the electrons loss or gaining of electrons. Instead you are looking at if you have larger number of oxygen atoms increasing through the reaction, you have oxidation reaction, and if you have less number of oxygen from the starting compound, you will have reduction. So the oxidation means I'm increasing the number of the oxygen atoms in my compound. So it is easier than the inorganic compounds. You could see that the reduction will be opposite to the oxidation. Instead of increasing the number of oxygens, you will have an increase in the number of the hydrogens, or a decrease in the number of oxygen, but in that compounds actually there is no decrease in the number of oxygen. It increased the number of hydrogens. So instead of starting with 6 hydrogen atoms, you end up with 8. So you increased the number of the hydrogens. This is why reduction happened. By that, we came to the end of introduction to organic chemistry. We talked about organic chemistry, introduction to organic chemistry, the type of compounds, naming organic compounds, functional groups, isomerism. Also, we talked about reactions in organic chemistry. In the next video, I will start talking about the hydrocarbons. So we will be focusing on the hydrocarbons. If you need more advanced organic chemistry videos, you will find a list of organic chemistry videos that is for advanced students that studying organic chemistry in more details. Until next video, thank you and goodbye.